In the last video, there is a simple question asked: 4700, how many significant figures? See, these are called as trailing zeros, end zeros, terminal zeros in a non-decimal number. So significant figures are only 2. And a into 10 power b notation is there. What is that actually? What is that? A is lying between 1 to 10, right? And 10 power b. So what is 10 power b? 10 power b is the order. Generally we had seen a human man has a mass of generally a order of 10 power 2 kg. So nearby 100, below or below 100, nearby that. So now b is called as order of the magnitude. So any number with the help of scientific notation we can write. With the help of scientific notation we can set any number to be required significant figures. Now we shall see what are the rules for arithmetic operation. With significant figures. Right. First let us see additional or subtraction. In case of addition or subtraction, what are the rules that are followed in a final answer? Okay, the final answer or final result of all doing addition or subtraction should contain or retain as many decimal places as many decimal places as there as are there as are there in the number with the least decimal places. Simple logic. Just you observe that, compare all the numbers after the decimal, how many digits are there. Then we will easily find out. See a simple example. 436.32 grams, we add it. 227.2 grams, we add it. 0.301 we will add it. So 1 2 8 decimal 13 5 6 6. So this is what actually we know in the lower classes what we learn. But according to the rules of arithmetic operation and significant figure setting, let us see that how many decimal places are there after the decimal point, how many digits are there after decimal. Two digits are there. Two digits are there. Here after decimal, how many are there? One digit is there. And here after decimal, how many? 1, 2, 3 are there. Three digits are there, right? So compare 3. Compare 3. Now, how many digits should have after decimal in the final result? I opted final result should contain as many as decimal places are there in the number with least decimal places. So this you choose it. This is a least decimal 1. After the point only one decimal digit. After the decimal one digit is there. The answer should have also after decimal point, it should have least one digit only. Have one digit only. So shall I write this one? 1 can be dropped, 2 can be dropped, 8. This is the final answer. This is the final answer. Right? So this is addition. Let us see subtraction is there. Let us see. So 0.307 minus 0.304. What is this? 0.003 meters. So 3 digits, no issue. 3 digits. At least is 3, no issue. Right? If you want, how many significants are there? Leading zeros are not counted. Shall I write it as 3 into 10 power minus 3 meter? No issue. If you write it in the form of scientific notation, it's no issue. So the rule for addition and subtraction are also same. If you want to find out simple logic, 7.823 minus 6.2. So how to write this one? 3, 2, 6, 1. But the decimal digits after the digits after decimal point is 1 and 3. So what is the least one? Least one is 1. So it should contain after that 1.6 only. 3 can be dropped, 2 can be dropped. That is a rounding off. In case of the rounding off, we will do that. So answer should contain one digit after decimal in case of addition and as well as subtraction. Right? Now multiplication or division. Multiplication or division. How? What is the condition for it? The final result result should retain or should contain as many significant figures as are there in the original number with least significant figures. So here the significant figures plays a prominent role. Example, mass by volume density will calculate 4.237 divided by 2.51, right? Now, how many digits are there in the numerator? 4. How many here? 3. In the numerator 4 are there, in the denominator 3 are there. So what is the least one? Between these two, this is called as least one. So answer should have 3 significant figures. Answer should have 3 significant figures, right? So this is a simple the way we can write it, right? Now we shall see a simple problem for the case of multiplication and as well as division also we will write it. Right. This is a simple problem. Each side of the cube measured to be A is equal to 7.203 meters. What are the surface area and as well as volume of the cube? So cube has how many surfaces areas? This is so 1, 2, 3, 4, 5, 6. 6 faces are there. So each surface area is a square. Total surface area six into a square. Similarly, volume of the cube is a cube, right? We'll solve that one. Surface area of the cube is equals to 6 into 7.203 whole square. 6 into 7.203 . 203, right? The answer, if you make it and calculate it, 311.299. Of course, if you use 254 meter square is a unit. What is the final answer? Actually, this answer having 1 2 3 4 5 6 7 8 9 9 digits are there. 9 digits are there, but answer should this is multiplication. What is a condition are there? Condition is final result should retain as many as significant figures are there in the original number with the least significant figures. Here least significant figures. How many are there? Least means 4. Least means 4 here. We should write it 4. So 311 point. So 5 dropped. Sir, 4 dropped. So before 2 is there, this is also dropped. 2 is there, this is also dropped. 9 is there, we will add 1 to preceding digit. So 9 plus 1, 10, 0, 3. This is 311.3 meter square. This is the answer. How many digits are there? Here 4 significant figures are there. 4 significant figures are there. So this is. Now what is other problem here? Finding a cube. Volume is equal to a cube. A cube means here 7.203 into 7.203 into 7.203. What is the answer should contain? The answer should contain only 4 digits, right? It is coming out to be 373.714 meter cube. So this can be dropped. This is dropped but added to be 1 to this one 8. This is 8. If you drop it now again, this can be 5. 5 can be dropped 6. Now this can be, if you said to be rounding of concept, 373.7 meter cube, right? If you become it is 2, actually again it can be dropped because 7 is there, no issue. This is called answer, final answer setting, right? We shall see another problem again. 5.74 grams of substance of occupies 1.2 centimeter cube. Express its density keeping the view of scientific notation. So mass is equal to 5.74 gram. Right. Volume is equals to 1.2 centimeter cube. Density is equals to mass by volume, 5.74 grams by 1.2 gram per centimeter cube. So how many significant figures are there? 3. How many significant figures are there? 2. Answer should contain only 2. It is a division. Earlier we had seen in the case of multiplication. Now we are seeing this case of only division. So answer should come out to be gram into gram per centimeter cube. This is the answer, right? So this is a simple concept. Rounding of a digits. Uncertain. Rounding of uncertain digits. How to rounding off? Last digits how to be cut off. So if you don't want to say more number of digits in the number, the last digits, the trailing digits are to be cut off or cut down with the proper rules, right? How to go with a simple example and how that the rules are there. Okay. See, suppose 2.746 is there. How many significant figures are there? 4. I want to set significant figures to 3. I want to set 3. How to write this? We always check that the last digit we should confirm either it is 5 or greater than 5 or less than 5. So for these conditions the rules are different. Now 6 is there, it is greater than 5. It is greater than 5. Right, okay. It is greater than 5. Now we check preceding digit again. Preceding digit of 5. Now this 4. The preceding digit is 4. Or what? It is 4. But once you see that it's greater than 5, it is greater than 5, simply what we write it as, we should write it as a confusion that either you write it as 2.75 or 2.74, which of the correct. Okay, now for second one we'll confirm it either 2.74 or 2.75. Again 2.742 is there. What you do? It is less than 5, right? Less than 5. Simply you cut it and you will write it as 2.74. Okay. Next, if it is 5, another one 2.225. This is how many significant figures are there? 3 are there. 3 are there. So 5 is there a condition equal, either it is 5 or like 5. I want to make it 2. I want to make it 2. Now how to write? So simply whatever you want to write it as 2.2 because the preceding digit is even. If it is odd, you raise it 1. If it is even, just leave it. Okay. Now what is the answer? Here it is greater than 5, right? Now this is the answer. So add one preceding digit if it is greater than 1. If it is less than 1, just leave it. If it is equal to 1, check the preceding digit. Check preceding digit whether it is even or odd. Whether it is even or odd. If it is even, just leave it. If it is odd, raise the one to preceding digits. So I will write simple answers, then you will understand how it is. 3.89. I want to set it for 3 significant figures. So 3.79, 8.223. This is 4. I want to set it 8.22 only. 6.755. 4. I want to set it 3. 6.76 because 5 is there and this 5 is odd. So raise 1 to its preceding digit. Raise 1 to its preceding digits. Right? 8.1121. 5 is there. You have to set for 8.112. Right? 6.725. Now 4 is there. Now I will write it 6.72. 3 only. So greater than 5, just you add a preceding digit, add 1 to preceding digit. Less than 5, just leave it. If it is 5, check the preceding digit is even or odd. If it is even, just leave it. If it is odd, raise 1, then last 5 can be cut down. So this is a simple analysis of particularly rounding of concept.